Let's say you're trying to create a Word document and your internal storage device stores the Word application, right? What happens is it copies the application software and the document onto the RAM, which will then open on your client monitor when you go ahead and press it. And let's say you type a sentence or add some images to the Word document. Essentially, what you're doing is you're adding a few bytes of Word or your image onto the RAM. So it doesn't go directly to the internal storage yet, okay? And when you make that change, it goes ahead and updates your document view or whatever you see on your screen. So your RAM here not only processes your request of typing or adding images, it also updates whatever you need to see, basically responds to your request. And when you go ahead and press save, it then stores your progress onto the internal storage. It stores your saved file onto the internal storage. So remember, when you use Word, you are not directly saving onto the internal storage until you press save. Whatever you're seeing on the screen is due to your RAM storing and updating and responding to your request on whatever you're writing. So, what happens if you do the same process, but now you power off your machine before you even saved? Of course, that means you can't save because whatever's stored on your RAM now will be deleted. So you can't go ahead and save it. So that is why in recent days, Microsoft Word has gone ahead and implemented a autosave process that detects an abrupt shutdown to allow for data to be saved onto the hard disk, and only when you go ahead and choose that autosave the next time you restart your computer, it will actually redisplay whatever work you've done and did not mean to shut down. Similarly, let's look at gaming. So when you start up a game, let's say Modern Warfare, you load it onto your RAM, okay? Your internal storage device doesn't go straight up to your display and you don't directly interact with your internal storage. You go ahead and open your internal storage. Let's say when you're in your game, you shoot your enemy. When you're actually shooting, what you're doing is you're requesting a shot to take place within the game, within the application of the game. So what that does is the RAM will respond to you saying, okay, you've done your shot. There's an image or there's a process of recoiling from that shot. So the RAM updates your game process, okay? And this RAM could be that RAM stick or it could be the RAM from the GPU, but either way, it's from RAM. And when you go ahead and finish, let's say, your mission, so after this loop of shooting requests and updating the game progress temporarily for you, only when you actually save the game progress do you actually store anything on your internal store on a permanent basis. So that's why they always recommend you to save, because only when you prompt the save, unless there's autosave, do you actually store anything on a permanent basis on your internal storage.